Let's say you, a researcher or a student, have a monolithic application that involves retrieving data from a database, reformatting the data, running analysis, and transferring it to a designated site. Scientific workflows help break down a multi-step monolithic task by describing the dependencies between the tasks and establishing a data workflow. In most cases, they are described as directed acyclic graphs, where the nodes are tasks and the edges denote the task dependencies. So you now know what to do if you have a complex computational experiment. Find the inherent DAG structure in your application to easily create a scientific workflow. The tasks in your scientific workflow can be anything from short serial tasks to very large parallel tasks. You have successfully built a computationally intensive workflow. But what if you need more storage and computing power? This is where Pegasus can provide tools to get your job done. Pegasus is a workflow management system that lets you create and manage the execution of your scientific workflow. Without any modification, your script can be easily and automatically run over various execution environments like HD Condor, grid infrastructures such as Open Science Grid, Amazon EC2, and Access resources. The same workflow can run on a single system or across a heterogeneous set of resources. Pegasus heavily leverages HD Condor DAGman to locate the necessary input data and computational resources automatically and manage storage space for executing your workflows. You can create a workflow using any of the Python, Java, or R Pegasus APIs to help facilitate the smooth running of your experiments. Pegasus comes with command line management tools for debugging, status checking, and monitoring your workflows and its resources. Pegasus is now part of Access, enabling users to run high-throughput workloads across multiple Access resources. Access is a virtual collaboration funded by the National Science Foundation that provides access to digital resources, consulting, training, and mentorship. You can run Pegasus workflows in Access, leveraging resources from across many campuses. The entire process of workflow creation in Pegasus Access remains the same. It comes with predefined workflows such as Jupyter notebooks that can be easily modified as per your application. To bring in the resources required for your application, Pegasus Access comes with a dedicated Open On-Demand web interface. We currently provide resources from Purdue Anvil, SDSC Expanse, and PSC Bridges 2. As a result of Annex creation, an HD Condor pool is created as an overlay across one or more Access resource providers. The HD Condor Annex easily submits your pilot jobs to these Access resources. You can use the same command line tools to manage and monitor your workflow. Now, we dive into the steps to set up the resources and environment for building and executing the workflow. To get started, use your web browser to log in to access.pegasus.isi.edu using your Access credentials. To access the resources, you have to have an active Access allocation. You have to log in to the resource provider via the Open On-Demand instances. Run a resource provider-specific command to authorize the SSH key and find the allocation ID. The steps for configuring the SSH keys and the resource provider-specific commands to get the project ID can be found in the documentation. The next steps involve creating and submitting the workflow from the Access Pegasus environment. Using the Python Pegasus API, define your workflow in terms of each task, that is, the executable that will be run, the input files required, and the output files produced. Pegasus will automatically infer dependencies between the tasks based on the input and output files. Once you have built the Pegasus workflow, use HD Condor Annex to bring the required compute resources across Access resource providers. This is called the planning phase. You can create an annex with the Annex Create command. If you have an Annex running and want to add more resources to your project, use the Annex Add command. Once you submit your workflow and it's up and running, Pegasus will handle the movement of data between the staging location and the site where the job is run. You can use Jupyter Notebook or command line interface to monitor the workflow in HD Condor Annex and debug them if any errors occur. The status of your Annex can be displayed with the help of the Annex Status command. It will give you an overview of the resources allocated and how long they will be available. You can start exploring with your tutorial Jupyter Notebook for a quick understanding of how Pegasus works. Go to access.pegasus.isi.edu and create an interactive session. There, you will find the tutorial notebooks. The first lesson will give you an idea of creating and working with Diamond workflows. Further lessons deal with debugging and command line tools. For detailed Access Pegasus documentation and setting up the HD Condor Annex, you can go to the Access Atlassian link. If you'd like to learn more about the Pegasus project, check out pegasus.isi.edu.